So today we're going to talk about exponential equations with uncommon bases. And the way that happens is, if you remember from our previous class, we made a common base by looking at our numbers and trying to see if they had a prime factorization that worked out the same on both sides so we can have the same base. So in this case we can turn 2 to the x is going to stay the same, but we will change our 16 into 2 to the 4th. We can then set the exponents equal to each other, and we know x is 4. Now, that only works if you can make a common base. If you can't make a common base, like in this case, 15 can't be written as 2 to any particular power, we need an alternative method. So the alternative method is using what's called a logarithm, which is known as the inverse function of the exponential function. So the exponential function is b is equal to b to the x is equal to y, meaning the base to the power of x is equal to a certain result. So we'll call this the result. This will be the, it's actually technically known as the power. This is why we call raising things to a power, but this is called the power. This is the exponent. And this is called the base. And as soon as you have these problems in this form, which is what most of these examples will be in, we can write it in logarithmic form. So logarithmic form looks like this. It'll be written as log, using the same base, will give you a particular value, the power, when the exponent is equal to a certain value. So this is still the exponent. This is still the power. And this is our base. So using the previous example, we can rewrite that problem in logarithmic form by writing log of base 2, because the base was a 2, of the power, which is 15, is equal to x. Now this is something that can be calculated on your calculator. Now, I know that the number that we're going to get is going to be less than 4, because 2 to the 4th was equal to 16. And 2 to the 3rd is equal to 8. So this should be some decimal value that we wouldn't be able to find without guessing and testing every possible decimal, which is what a calculator is going to be doing for us. So I'm going to type this into my calculator, and I will tell you what it gives me. Using my calculator, if I press math, I'm using a TI 84 plus. I press math, and then just scroll down to log base. And it will allow me to type in this exact expression here. So when I do that, base 2 of 15, I get 3.906890596, and then the calculator runs out of room to provide numbers. So the decimal is smaller than 4, and it's bigger than 3. It's closer to 3.9. On a test question, we would have to tell you what to round to. Our worksheet tomorrow, we will be rounding to the nearest hundredth for all examples. So this is the tenths, this is the hundredths, meaning we would look at this 6 and round this up to 3.91. So this is the approximate exponent that would be needed to get 2 to any particular power to be 15. Now, these same types of problems can be done if the exponent looks a little bit crazier. So we're going to take a look at one more example with a more complicated exponent. We're going to do the same thing. We're going to write log of base 2 of 10 is equal to x plus 2. So again, this is a value that we can find in our calculator. So I'm going to do that now. I'm going to round to the nearest hundredth, as we will with most questions in our class. And I get 3.32. So that is the exponent that I need to get 10, but that isn't the question. So I'm just going to write x plus 2 and solve for x. So x is going to be equal to 1.32. So if that value was plugged in here, the exponent would be 3.32, which would give us 10. Another thing to concern yourselves, if your calculator doesn't have the function log base in it, you can also write any particular logarithm in another way. So log with a given base trying to obtain a particular value can be rewritten as log y divided by log base. So this is in your calculator. The button for log for sure is in there. Log without a base listed is standard is log 10. So this is really log base 10. And it doesn't really matter which log base you use when you're doing these problems. If we were to type in log 15 over log 2, we should get the same decimal as we did before. Now, it shouldn't matter which log base we use. Commonly, you'll also see a button on your calculator called ln, which is natural log is what it stands for. It means a base of e, which is a special constant like pi. So if you saw ln, it's the same thing as using log in these cases. That should be all you need for tomorrow's lesson. If you have any questions, make sure